Good morning, ladies and gentlemen. We are going to start logarithms. It's actually one of my favorite parts of Algebra 2. I really enjoy working with logarithms. So we're going to talk about exponential functions and log functions, and then we're going to convert back and forth between the two. We will spend 2 or 3 days on the beginnings of logarithms just to make sure that we get this set very solid so that it's a good foundation. All right. In the past, we would do something like this. 2 squared equals 4. Okay? Or we might have x plus 2 to the second equals 10, and then we would solve. So we're used to seeing a variable in what I call the down position, in the base position. Okay? But now what we are going to do is we're going to move our variable up. And we've already been working with this a little bit. Okay? The only way that I can solve for a variable that's in the exponent position is to use either my exponential functions or to convert it to a logarithm and solve it that way. Okay? So when I see a variable in the up position or in the exponent position, I have basically going to bring in my logarithms to solve. So let me kind of show you the difference between the forms. So logarithm form, okay, is going to be the log base b of x equals y. So that's how you say it. I would say the log base b of x equals y. It is very important when you're working with logarithms to make a distinction that the b is a subscript, that it's low and not high, because we're going to have subscripts, we're going to have superscripts or exponents, so you want to be really careful with the way that you write it. Okay? I can take this form and convert it to exponent form. Okay? And I will spend significant amounts of time going back and forth in between these two forms. So remember, this is log base b of x equals y. So the way that I would write this is the base is b to the y equals x. Okay? These two statements represent exactly the same thing. So the base to the answer equals this. All right? So let me do some examples where I am converting from log form to exponent form. So oftentimes when we talk about logs, we call, instead of saying logarithm, we just say log form. Okay? And then same thing for exponent form, I'm just going to write exp. All right, so let's do some examples of converting. So if I'm given the log base 2 of 8 equals 3, I would convert that to exponent form by saying you always start with the base. 2 to the third equals 8. And we know that that's true, right? 2 to the third equals 8. My next one, what if I was given the log base 4 of 1 equals 0? If I convert that to exponent form, I start with my base. 4 to the 0 equals 1. Anything to the 0 power is 1, so that is also true. So then the next one, what if I have the log base 12 of 12 is 1? And I'm going to convert that to exponent form. Starting with the base, I would say 12 to the answer equals 12, and 12 to the first power does indeed equal 12. Okay? So I know it seems a little bit weird, but we are using this type of information to be able to solve an equation where the x is in the top. All right, I'm going to continue and do a couple more. Same thing. So I'm going to start with the log form. I have 381 equals 4. And I'm going to convert that to exponent form. So I'm going to do 3 to the 4th is equal to 81. And I guess you still can't see it, so it's kind of hard to know what I'm doing. All right, so they all are giving me true statements, but it's nice to see how they compare. The next one would be the log base 14 of 1 equals 0. In exponent form, it would be 14 the base to the 0 equals 1. Again, it's a true statement. The next one, the log base 1/2 of 32 is a negative 5, okay? So now I would say start with the base, 1/2 raised to the negative 5 is equal to 32. All right, so see, I do need to be really careful with my bases and my exponents, okay? All right, so that's the beginnings of our log form and exponent form. So now in the next example, I'm going to show you how we use this. So I'm going to evaluate without a calculator. Okay, so I'm just going to do several examples for you. So the first one, you're going to be given the log base 4 of 64, and it wants you to find what the value of that is without using your calculator. So when I do that, I always add an x, or whatever variable you want to use, so that I can convert it back to exponent form, okay? So like the examples we just did, now I'm going to say 4 to the x is equal to 64. Well, my x is in the up position, and 4 is the base. I know that 64 is a power of 4, and I need to have the same base to be able to solve this type of equation. Okay, so I'm going to rewrite 64. So I'm going to say 4 to the x is equal to 4 to the third. Notice that my bases are the same, so I can solve the baby equation at the top, and I would get x is equal to 3. Okay? To be able to solve an equation like this, to be able to solve it from exponent form, the bases always have to be the same. So sometimes the challenge is finding, if I know that this base is 4, I'm hoping this base is 4. All right, so let's do some more examples. The next one, I'm going to have the log base 5 of 0.2, and I want to evaluate that without my calculator. So again, I'm going to add an x because it helps me convert back to exponent form. So I'm going to say 5 to the x is equal to 0.2. Well, that's weird. I can't solve unless I can rewrite this to make the bases be the same. So I'm going to rewrite this as 2 over 10 because that's what 0.2 is. Well, now I can reduce it to be 1 over 5. Well, that's pretty polite, and I can rewrite that as 5 to the negative 1. So now I have 5 to the x is equal to 5 to the negative 1. That's pretty polite. So now the bases are the same. Solve the baby equation at the top, and I get x is equal to a negative 1. So that actually didn't turn out as bad as it looked like. The third one, okay, so I'm going to have the log base 2 of 32, evaluate without a calculator, so I'm going to add my x. So if I go back to exponent form, I'm going to say 2 to the x is equal to 32. Well, I need 32 to have the same base. I know that 32 is 2 to the 5th. Okay? If you don't know that, you could experiment with your calculator. Notice now that my bases are the same. Solve the baby equation at the top, and I get x is equal to 5. Okay? I have one more example for these. Number 4, I have the log base 27 of 3. I want you to evaluate without a calculator. So I'm going to add my little x. Now this time I'm going to do 27 to the x is equal to 3. Well, 27 to a power is not going to give me a 3, but 3 to the third gives me 27. So this time I'm going to rewrite the left-hand side. So 3 to the third raised to the x is equal to 3. And if you'll remember from our last chapter, a power to a power is multiplied, so 3 to the 3x is going to equal 3 to the 1. Now my bases are the same. I can solve the baby equation at the top, so I'm going to get 3x equals 1, divide both sides by 3, and I get x is equal to 1/3. Okay? So that wasn't as bad as it looked like. All right? We're almost done. Today's wasn't actually very long. So now let's talk about the bases for the logarithms. Okay, there are 2 bases that we use on our calculator. So your calculator, and I'll show you in a minute, your calculator has 2 bases that it uses. The first one is called a common log, and that means that the base is 10. Because that's called a common log, we usually just write this as a log. So anytime you see a log without a base, that means that its base is 10. Okay? The other base that your calculator uses is called a natural log. And remember, when we did natural exponential equations, that meant that we were using an e. The same thing happens for logarithms, so I'm going to have a log base e. But we rewrite that, because it's a natural log, we rewrite it as ln. Okay? So the only difference between a common log and a natural log are the bases. So now let me show you your calculator. Okay, I think I'll put it over here. There, maybe you can see it. Actually, and I'm going to zoom in just a little bit so you can see this a little bit better. Okay, and then I'll back out when we keep working on our examples. Notice that I have two buttons on my calculator that say log. This one is a base 10, and then right underneath it is the natural log. That one is base e. All right? So that's where my two log buttons are on my calculator. All right, so now let's use that information and evaluate. So here's our next example, and it's going to say evaluate. Notice that it doesn't say without your calculator, which means, yay, woohoo, we get to use our calculator. Okay. All right, so the first one is going to be the log of 8. Okay, and let me show you what would happen if we had tried to do this by going back to exponent form. Okay, if I had tried to go back to exponent form, I would have added an x. My base, even though it's not written, is 10, and so I would get 10 to the x is equal to 8. I can't do that math because 10 and 8 have nothing in common as a base. So that means that I can do that, but I haven't taught you that math yet. So I'm going to do this in my calculator. So I bring out my handy dandy calculator. Remember, if I'm using a common log, it has a base of 10. So when I turn my little grapher on, I'm going to do the log of 8, close, and there's my answer. Okay, so the log, you can't see it, sorry, is going to be 0.903. All right, so that's the solution, and I did that by pushing buttons on my grapher. Okay, there you go. How's that? All right, so the next one would be the natural log of 0.3. Again, my base, even though it's not written, is e. And if I tried to do this one by going back to exponent form, I would get e to the x is equal to 0.3. Those two things aren't going to have anything in common. So I'm just going to do this in my grapher. The glare is really bad, sorry. So I'm going to do the natural log, and then I'm going to do my e, okay? Oops, sorry, it's 0.3, 0.3, close, and then I'm going to hit enter, and there's my solution. So it is a negative 1.204. Okay, so there was the solution that I wrote down. Alrighty, so that's just a little bit about using your calculator, so there will be times that you have to have a grapher to be able to do this math. Alright, so now let me give you your problems, and then we're done for today. Kind of a nice, easy start to logarithms. Okay, they're actually really fun. One of my favorite things about Algebra 2. Alright, so the first set says rewrite the expression in exponential form. Okay, so the first problem is going to be the log base 7 of 49 equals 2. The second one is going to be the log base 2 of 16 is 4. So remember, I'm wanting you to take it from log form and put it in exponent form. Your next couple say evaluate without a calculator, which means you have to show the math, convert it back to exponent form, and solve it that way. Okay, and my little thingy's tilted at a weird angle, sorry. So number 3, I'm going to have the log base 9 of 81. And number 4, the log base 4 of 2. Alrighty. And then I have one more problem, so I'm just going to write it over here on the side. It says evaluate. Remember, this means that you get to use your calculator. Woohoo! So number 5 is going to be the natural log of the square root of 5. Okay? And then number 6 is going to be the log of 110. Alrighty, those are your problems for the day. Good luck, and then I will see you tomorrow.